What if tomorrow humanity decided to terraform Mars? This isn't just science fiction, it's a real question scientists are asking now. The goal: to transform the cold, barren red desert of Mars into a living, breathing world, a second Earth. It would be the single greatest undertaking in human history. Among all the planets in our solar system, Mars is the most Earth-like. It orbits in the Goldilocks zone, has a similar day length, and even seasons. But it's a world of extremes, freezing, with a thin atmosphere and deadly radiation. Terraforming, a long-term process to increase atmospheric pressure, raise temperatures, and generate oxygen. Terraforming Mars is a generational challenge, a lifeboat for our species against existential threats. But this grand vision carries an astronomical price tag and a profound ethical question. Do we have the right to remake another world, potentially destroying native life before we even discover it? So, why Mars? It's our neighbor, a reachable destination for our current technology. Unlike Venus, no scorching hellscape or the distant gas giants. Mars is a rocky world like our own, a fixer-upper on a planetary scale. A Martian day is astonishingly close to Earth's 24-hour cycle. Mars also has 4 distinct seasons, much like Earth, due to a similar axial tilt. These familiar rhythms make Mars feel less like an alien world and more like home. Mars was once a wet world, but is now a frozen desert. Overwhelming evidence suggests it had enough water for a global ocean. That water is still there, locked away as ice at the poles and deep beneath the surface. We just have to liberate it, restoring Mars to its former, more habitable state. Mars is an unassembled kit for a new world. The fundamental building blocks, carbon, oxygen, and nitrogen, are all there, locked in the soil and atmosphere. The habitability puzzle. The first challenge is the airless void. Mars's atmosphere is less than 1% of Earth's, a near vacuum so extreme that water boils and freezes simultaneously. Without a pressurized suit, a human's own body fluids would boil away. Even releasing all of Mars's frozen CO2 isn't enough to solve this. An invisible killer awaits on the Martian surface: radiation. Without a magnetic shield, Mars is constantly bombarded by lethal high-energy particles. One proposed solution: an artificial magnetosphere. Mars is dangerously cold, with an average temperature of -80 degrees Fahrenheit. To warm it, we could deploy enormous orbital mirrors to focus sunlight on the poles, or build factories to release powerful greenhouse gases into the atmosphere. Nitrogen is another critical gas, but Mars's atmosphere is nitrogen poor. Fortunately, NASA's Curiosity rover found nitrates locked in the soil, opening the possibility of mining the regolith and heating it to release the needed nitrogen gas. Even with a thick, warm atmosphere, Mars would have virtually no oxygen. The final challenge is creating breathable air by seeding the planet with genetically engineered microbes, a slow, centuries-long process to kickstart a new, great oxygenation event. To warm Mars, we must kickstart a greenhouse effect. We could use giant orbital mirrors to melt the polar ice caps, or darken their surface to absorb more solar heat. To create a stable atmosphere, we'd build massive industrial plants on Mars. These automated factories would use Martian materials to pump out powerful heat-trapping gases, thickening the atmosphere. If Mars is short on water and nitrogen, we could import it using comets and asteroids. We'd become comet handlers, sending powerful spacecraft to guide them on a delicate, multi-year journey to Mars, an audacious plan to accelerate terraforming. Without a magnetic field, the solar wind would strip away a new atmosphere. To make it permanent, we need a shield, a giant satellite creating an artificial magnetosphere. With Mars warmed, we seed life to create oxygen. Genetically engineered microbes condition the soil while algae fill the seas. Over centuries, mosses and forests finally turn Mars green. Terraforming Mars is a generational commitment, taking centuries, perhaps millennia. The timeline is staggering. Warming the planet could take a century, building an atmosphere, a few more, but creating breathable air would take at least 1,000 years. The cost? Trillions. It's the ultimate act of delayed gratification. Before Mars can become a garden, it must first become a planet-wide factory. Autonomous robots will build the vast infrastructure needed to pave the way for a new world. Terraforming Mars requires unprecedented global cooperation. A new terraforming alliance would manage the complex logistics, but the mission's success would depend on maintaining a unified, peaceful society for centuries. The path to a terraformed Mars is not a single giant leap, but 1,000 incremental advances. The real question is whether we are willing to take the next small step today.